Okay? So we will have our third example. So this type of circuit, so we will have dependent sources. Let's say I have a positive, negative, independent 2-volt source, 8 kilo ohm resistor, a dependent source which is 0.001 VAB, and this is linked to a ATI, dependent current source, current dependent current source. Bakit current dependent siya? So take note kasi ay current to ng circuit na to. This is your I wherein that I is dependent. Next is your 50 kilo ohm resistor. And then your voltage VAB. This is your positive, negative voltage VAB. And then your terminals A and B. The question is that find for the thevenin equivalent circuit. Thevenin and Norton equivalent circuit. Okay. So how will you do it? So let's go back to our discussion a while ago. That when there is a dependent source, you will still short the independent voltage source and open the independent current source. Then let the dependent source be there. The next is you will series a current source or a voltage source into the terminal of your RL. But in our RL, in this problem is that your terminal AB wherein RL is 0, therefore shorted siya. And then, after that, if you will series a current source or a voltage source, you will perform the Ohm's law to get for the value of your RTH and your RN, which is basically equal to Vs over assume current source. If you assume a current source, let's say 1 ampere, or Vs over Is, or 1 volt divided by Is. Okay? Or you're calculated. If you will assume a current source here, you will calculate for the value of your voltage source. If we assume a voltage source here, we will calculate for the value of your current source. Okay? So, let us find for the value of your RTH. So, solving for RTH, how will we solve this one? So, gaya ng dati, short natin yung independent source. So, we'll have the independent voltage source that is shorted. Okay? And then we have an 8 kilo ohm resistor. And then, you have our positive, negative, 0.001 VAB. And then, we have our ATI current. Going down. And then, we have our 50 kilo ohm resistor. Actually, pwede natin i-source transform to. Okay? But basically, no. Okay? This is your AB. Okay? Actually, we can take this terminal out and then we will source transform it. So, next is that I will series a voltage, current source. Bakit current source yung pinili ko? So, basically, para sa akin, mas madali yung current source or voltage source depending on the situation. So, in this situation, I will use my current source. Current source, 1 ampere. Okay? But basically, pag gumamit ka ng 1 volt dito, that will be the voltage of your VAB. And then, you may say that your VAB is equal to 1 here. But probably, I will use my 1 ampere. So, upon using my 1 ampere current source, so therefore, I may have a nodal analysis at this node. And then, I will ground this node. So, I will have the current using KCL at node A. So, take note that this is also VAB because it is within the terminal of your 50 ohm, which is in parallel with your VA. Okay? So, therefore, I will have my 1 ampere current source going up. And then, another current going to your 50 kilo ohm or your I 50 kilo ohm. My I 50 kilo ohm is just equal to VAB all over 50 kilo ohm. Okay? So let's have a KCL at node A. So we'll have a current going into your node A. We have negative VAB, negative I 50 kilo ohm minus 80I plus the current 1 ampere equals 0 via conservation of charges. So our I50K is equal to VAB over 50, right? So we have negative VAB over 50 kilo ohm minus 80I, which is equal to negative 1. Okay? So madali lang tong ganitong mga circuits. Because you can get already your VA and VB. Okay? Next is that we will have the value or this circuit. So take note that this is also your I which is mentioned in this dependent source. Okay? So therefore, KCL at loop 1 so we'll have a value equal to 8 kilo ohm multiplied by I plus our 0.001 VAB. So take note, this is solving for RTH. Okay? So, since you have already two equations to unknown, you can solve this within or using any method that you would like. Probably, since alam ko namang nasa bahay kayo, ang gagamitin yung calculator method. Okay? So, two equations to unknown yan. Just take note of the positions of your VAB and your I. Okay? Dapat nasa first column yung VAB nyo at second column lang yung I nyo. So, let's start. So, 5, 1. Both 5, 1. So, we have negative 1 all over 50 times 10 raised to 3. So, close and open parenthesis. Negative 80 equals negative 1. Then, at the second column, so we have 0.001 VAB and then 8 times 10 raised to 3 I1 equals 0. So you will see that your VAB, is equal to 100,000 volts. And then your I, syempre hindi na yan kailangan, which is equal to negative 0.025. 0.0125. Okay? So as I have said, when you have assumed a current source, you will find for the value of the Vs. So take note that we have assumed a value of your 1 ampere as our current source. And take note that our VAB is in parallel with your AB. So therefore, my VAB is equal to the voltage source at 1. The voltage at this terminal AB. Okay? Which is basically the voltage of 1 ampere source. Yung terminal dito, yan din yung voltage niya. Okay? Therefore, I may say that my RTH is equal to voltage source calculated divided by our I assume, which is basically equal to 100,000 volts divided by 1 ampere. So there have my RTH is equal to 100 kilo ohm. That is our RTH. Next is that we will solve for the value of our VTH. So let us focus in this current diagram. So take note that your AB is open. Open yan, di ba? So we will have a look your current diagram or your circuit diagram. So let's have a look in this, let's say 1 prime. Look at your major source or your circuit diagram. So KVL, solving for VTH. Solving for VTH. So we will have a loop KVL at loop 1 at original circuit. So we will have a value equal to 8 kilo ohm plus 0.01 VO minus 2 volts, right? 8 kilo ohm multiplied by I plus 0.01 VAB minus 2 volts, okay? So we will have a value equal to 8 kilo ohm multiplied by I. So palitan natin yung kulay ng pen. So 8 kilo ohm multiplied by I plus 0.01 VAB 0.001 VAB minus 2 volts, which is equal to 0. Mapapansin nyo, hindi ko na nalagyan ng unit. So we have 8 kilo ohm I plus 0.01 VAB is equal to 2. That will be our first equation. Equation 1. And then our equation 2 will be syempre at the other node, right? So take note that this will be open. So we will have a value equal to KCL ako dito. So we'll have a KCL in this node. Take note, pwede akong mag-assume that this will be my ATIO and then my VAB and then my IAB, which is equal to 0. So therefore, we will have the same equation as this one. Okay? So we'll have negative VAB KCL at node KCL at node A. So this will be our node A. So we have negative ATI minus VAB over 50 kilo ohm. So we have negative ATI minus VAB all over 50 kilo ohm equals, so syempre pumasok yung IAB natin, but take note that our IAB is 0. So I will say that it is 0. Okay? So using your calculator, solving for the values of your I and VAB, so we will have both 5, 1 ulit. And then we have our 8 times 10 raised to 3 for our I, and then 0.001 VAB, which is equal to 2 volts. And then we have negative 80, so for our I, minus 1 all over 50 times 10 raised to 3 for our VAB. So we will have equals 0. So we will have a value of VAB equals our I is equal to 5 times 10 raised to negative 4 ampere, and our VAB will be equal to negative 2000 volts. Okay, so the Thevenin equivalent will be, we'll have positive, negative 2000 volts, and then our RTH, which is equal to 100 kilo ohm, and then our terminal AB, which is shorted. Okay, so therefore this is our Thevenin equivalent. So our Norton equivalent will be, this is your I going downwards because it is negative. But if you will act is as going upwards, therefore you will sustain the negative value. So negative 2000 divided by 100 kilo ohm, which is equal to your IN, in parallel with our 100 kilo ohm resistor, and then an open terminal for your RL. So we have negative 2000 divided by 100 times 10 raised to 3. So we have negative IN is equal to negative 20 milliampere. Okay, this is for the examples of our Thevenin equivalent.